Everybody asking how we doing, say we good. Don't need no one to tell me how to live just like they would. It ain't their business, but they in it, I don't know why. Revolved around my life after I found another.
Good day! We are the Chemist Duo! I'm Angel.
I'm Cecilia.
And today we are going to show you how fascinating enzymes is. So, let's bring it on!
Welcome to our science laboratory.
Do you know that enzymes are found throughout the natural world, playing essential roles in both living organisms and various environments?
You might be wondering why we're holding this kind of vegetable. Because these potatoes have enzymes, and basically, enzymes found in living organisms, environments, and food and industrial products.
Can you guess what will we gonna do to these potatoes right now? Well, let's find out!
Catalase in potatoes works over a wider range of temperature. Not all catalase enzymes are exactly the same, so they can vary depending on where they come from, like plants, animals, or bacteria. Experiment number 1. Factors that affect enzyme.
Temperature, fresh potatoes, hydrogen peroxide, knife and cutting board, beaker, ice, baking soda.
Cut equal-sized potato pieces and place each piece in a test tube. Add equal amounts of hydrogen peroxide to each tube. Keep one test tube at room temperature, one in a warm water bath and another in an ice bath. Observe and measure the time taken for bubbles or oxygen gas to for temperature. The warm water bath usually increases the reaction rate, while cold slows it down. Extreme heat denatures the enzyme. Next, let's test the pH. Place potato pieces in separate test tubes. Add 5 milliliters plain water in one tube. Add 5 milliliters and a baking soda solution. Add 5 milliliters of vinegar to one tube. For pH, catalase works best at a neutral pH. Acidic or basic conditions can reduce activity. And the last one, let's test the concentration. Use different sizes of potato pieces, small, medium, and large. Add equal amounts of hydrogen peroxide to each tube. Observe how the reaction rate changes based on the surface area of the potato. More enzyme, so that means it has a larger potato piece, generally speeds up the reaction.
Those are the factors affecting enzymes. Experiment number 2. Enzyme inhibition using pineapple and gelatin.
Fresh pineapple, canned pineapple, gelatin.
Okay, this time we are going to cook the gelatin according to its instruction inside the package. The preparation for gelatin, so we need to put these mixtures in a beaker. So measuring 100 ml, so we need 100 ml here. So 2 beakers. So we need 2. So this is 100 ml. Then another one, 100 ml.
Add a small piece of fresh pineapple to one container and a piece of canned pineapple to the other. Place the containers in the fridge to set. After a few hours, check which container has solidified. Fresh pineapple contains bromelain, an enzyme that breaks down proteins, preventing gelatin from setting. However, canned pineapple lacks active bromelain because the heat from canning deactivates the enzyme.
For temperature, in here, the warm water generally speed up reactions, so it's common to see more bubbles in warmer conditions compared to other test tubes, which is lowest at room temperature. For pH, potatoes plus hydrogen peroxide and water produce the most bubbles. potatoes contain an enzyme called catalase, and this enzyme speeds up the breakdown of hydrogen peroxide into water and oxygen gas. For concentration, bigger potato pieces have more enzyme, so they can break down hydrogen peroxide faster, producing more bubbles. Smaller pieces have less enzyme, so the reaction is slower. Experiment number 2. This experiment shows that fresh pineapple stops gelatin from setting because of the active bromelain enzyme, while canned pineapple allows gelatin to solidify because this enzyme has been destroyed by heat during canning.
And now, Chemist Duo signing off. Bye! See you next time!
Business, but they